Hi, my name is Erin Yoshida, and I'm a third-year orthodontic resident at the University of Washington. The title of my research is Real-Time 3D Analysis of Airborne Particles Produced During Orthodontic Composite Attachment Removal. A little background on my project. So as we all know, the outbreak of SARS-CoV-2 or COVID-19 and its rapid spread has led to a dramatic loss of human life and has devastated social and economic systems worldwide. The virus is transmitted through airborne droplets, putting dental practices at increased risk of spreading the virus due to the aerosol-producing nature of many dental and orthodontic procedures. In addition to viruses, aerosols can carry bacteria and dental particulates, which contain cytotoxic material such as BPA and adhesive monomer. Continuous occupational exposure to these entities may be contributing to the increased rates of chronic respiratory diseases in dental professionals. Various methods have been proposed to minimize dental aerosols, such as supplemental extraoral evacuation and the use of air-free handpieces without water supplementation. However, there's little evidence available on the effectiveness of these techniques. So this brings me to the purpose of my study, which is to determine existing strategies, so handpiece and evacuation system type, that most effectively minimize the aerosolized particle transmission when removing orthodontic composite attachments. This will be an in vitro study using 3D printed models with bonded composite attachments. I'll be testing 3 different handpiece types, so this includes air-driven, air-free, and electric, as well as combinations of high-speed intraoral section and extraoral evacuation. My research will be a collaborative effort with the Novoselov Research Group Lab at the University of Washington Mechanical Engineering Department. They've developed a novel sensor network consisting of aerospec portable particle sensors and an online cloud-based software which records, analyzes, and stores the particulate data from the sensors in real time. This novel system will allow us to place multiple sensors in a 3-dimensional array around an orthodontic operatory to not only collect data on particle concentration during the orthodontic composite removal procedures, but also track the dispersion of these particles in real time. While the UW Orthodontic Alumni Association has provided funding for several trials of piloting, the AAOF grant will allow us to realize the full potential of this project. We anticipate the money will help us fund 3 to 4 repetitions of standardized composite removal trials with up to 25 aerospec particle sensors placed in a 3D grid in and around the orthodontic operatory. The parameters of this experiment, including the removal of composite attachments, the use of handpieces that we commonly use, and the use of suction units that we currently employ, will result in valuable data that can provide information on the generation and dissipation of particulates in orthodontic offices and direct best practices going forward. While COVID-19 will hopefully become a well-controlled disease in the near future, the knowledge gained from this experiment has the potential to continue influencing aerosol and particulate management in all circumstances, as we always wish to minimize exposure for our staff, patients, and ourselves. Thank you so much.